Howdy. In this video, now that we've gone over how to do the basic flowchart of cylindrical shells, we're now going to put it into practice. So if you have not seen the previous video where I talked about this flowchart, stop this video, pause it, go back and watch this. That way, whenever we do the examples, it's going to be a whole lot easier to understand. Now, if you have this flowchart next to you, let's go ahead and systematically, I'm just going to set up every integral. I'll leave the actual integration to y'all, but I'm going to set up every single one of these integrals utilizing cylindrical shells. So let's take a look at number one. Number one, I want to find the volume of the region bounded by y equals 2x squared minus x cubed, y equals 0, and rotate it about the y-axis. First thing I want you to point out is, am I going to be using x's or y's? Well, notice how I have a function of x rotated about the y-axis. Whenever it's opposite, it's always cylindrical shells. Whenever they matched up, we use disk washer, but whenever they're opposite, cylindrical shells. Okay? Now, because I'm about a y-axis, everything's going to be with respect to x. So, the first thing you always want to do is find r. And so finding r, I come here, I ask myself, is it rotated about an axis, or is it rotated about a number? Well, it's rotated about the y-axis. So because it's rotated about an axis, r is simply just x. The last thing you ask yourself is h. Okay? And to deal with h, I ask myself, do I have one function, or do I have two functions? And in this case, I have one function. I simply have the 2x squared minus x cubed. So because I have just one function, your h is that function, 2x squared minus x cubed. Now that I have r, now that I have h, you just plug it into here. Therefore, what I'm going to have is that volume is equal to the integral of 2 pi, my r is x, your h is 2x squared minus x cubed dx. Now the last thing that I need are my intervals, my limits of integration. Okay? And notice here that you're bounded by h equals 2x squared minus x cubed and y equals 0. So if that's my region, that's what I'm bounded by, let's see where they intersect, because where they intersect, that's going to be my bounds in which I integrate to. So, setting these guys equal to each other, we have 2x squared minus x cubed equal to 0. I can factor out an x squared and make this 2 minus x is equal to 0. And then solving for x, I get that x is equal to 0 and x is equal to 2. And that's my region which I'm bounded by. Therefore, you're going to be integrating from 0 to 2. Alright, so now let's go ahead and do number 2. Number 2 is, it's bounded by y equals x squared and y equals 0. And it's bounded by x equals 1, x equals 2, rotated about x equals 3. The first thing I need to figure out is, am I using disk washer or cylindrical shells by seeing what it's rotated about and what kind of function I have. Now, if it's rotated about x equals 3, okay, here is x equals 3, this line. Notice how x equals 3 is parallel to the y-axis. So because it's parallel to the y-axis, I treat it like a quote-unquote y-axis. So, because I have a y-axis and a function of x, they're opposite cylindrical shells. So, I'll be doing everything with respect to x. Now that I've established that, I want to find my r, and after we find r, we're going to find h. Now, as for my r, I ask myself, what am I rotated about? Am I rotated about an axis, or am I rotated about a number? And I'm rotated about x equals 3. I'm rotated about a number. And so your a is equal to 3. Therefore, your radius, if it's rotated about a positive a, a positive 3, your r is equal to that a, that number 3, minus x. Okay? It's rotated about, because it's going to a positive a, it's going to be a minus that x. So your r is 3 minus x. As for my h, I see, do I have one function or do I have two functions? And I see that I have one function. That is y equals x squared. Therefore h is x squared. And now that I have r, now that I have h, let's go ahead and plug it into our equation. Therefore volume is the integral of 2 pi. My r is 3 minus x. My h is x squared. Of course, I'm doing this with respect to x. And as for my limits, where am I going from x equals where to x equals where, it actually tells me. You're going from x equals 1 over to x equals 2. So your limits are going to be from 1 to 2. Now let's go ahead and take a look at number 3. Number 3, you have x equals y minus 2 squared, y equals x, rotated about the x-axis. Alright, so I'm rotated about the x-axis, and here I have a function of y, but here I have a function of x. Well, what you want to do is you always want to pick the one that's going to make your life a whole lot easier, especially with this one. With this, you can say y equals x, x equals y. That's actually pretty easy. But looking at this first one, I have x equals y minus 2, the whole quantity is squared. I actually want to leave it as a function of y to make my life easier. So what I can do is I'm going to leave this alone, and I'm going to then say that x equals y. Okay, because if y equals x, x equals y. And what I have is I have two functions of y. I have two functions of y rotated about an x-axis. They do not match up. So cylindrical shells. And because I'm rotated about an x-axis and using cylindrical shells, everything is going to be with respect to y. So let's go ahead and find my r, and I'll find my h. I'm finding my r. What am I rotated about? Am I rotated about an axis, or am I rotated about a number? Well, I'm rotated about an axis, right? I'm rotated about the x-axis. So because I'm rotated about an axis, your r is simply your variable y. So your variable y, because I'm doing everything with respect to y. Now as for my h, do I have one function, or do I have two functions? Well, I've got two functions. I've got x equals y minus 2 squared, and I have x equals y. And so because I have two functions, we got to find quote-unquote top and bottom. And so let's go ahead and do that just like we did with area. And remember with that, how did we find top and bottom? Well, the first step was to see where they intersected, set them equal to each other. So I'm going to have y minus 2 squared is equal to y. I can expand this to make this y squared minus 4y plus 4 is equal to y. I see that I have a quadratic. So let's move everything over to one side, set it equal to 0, and solve for y. So I have y squared minus 5y plus 4 is equal to 0. Let's go ahead and factor and solve. And this factors into y minus 4 times y minus 1 is equal to 0. Therefore, I get that y is equal to 4 and y is equal to 1. So I found my intersection, so that's nice. I know my limits of integration. But now that I have where they intersect, let's see which one's on top. And the way we figure out to see which one is on top, remember how we took our interval, 1 to 4, and then we compared. So I had x equals y minus 2 squared, and then I have x equals y. And we pick a random number in between 1 and 4 in order to see, and plug it into both, in order to see whichever one is on top and bottom. Now I'm going to pick the number 2. You pick whatever number you want in between 1 and 4, but I'm going to plug in 2, so I plug 2 into both. Okay? And when I plug 2 into both, I get that x is equal to 0, and over here I get that x is equal to 2. And because 2 is bigger than 0, that tells me that my x equals y, that is your top. Just a quick reminder of how we dealt with that. So, therefore, now that I know my y is equal to my top, that means your other one has to be your bottom. So your h is your top, y, minus my bottom, y minus 2 squared. Therefore, your final answer, the way you would set up this integral, you would say that volume is equal to the integral of 2 pi. My r was y, and my h was y minus 2 squared dy. And as for your limits of integration, that's just wherever they intersect. And they intersected here at 1 and 4. You have to do a little bit of algebra to this y minus 2 squared. Go ahead and expand that to distribute and so forth. But this is how you would set up that integral. Last one, number 4. Number 4, I have y equals 18 minus x squared, y equals x, rotated about x equals 3. To get into the habit, I first want to figure out whether I want to use disc washer or cylindrical shells. So I take a look at what it's rotated about. I'm rotated about x equals 3. And so once again, here is x equals 3. And once again, we know that this line is parallel to the y-axis. So I treat it like a quote-unquote y-axis. So this is a y-axis, and I have functions of x. They do not match up, and that's why I'm using cylindrical shells. And so everything is going to be with respect to x. So now let's go ahead and find my r and my h. Okay. So let's go ahead and figure out how to find r. To find r, what am I rotated about? Am I rotated about an axis, or am I rotated about a number? And in this case, I'm rotated about a number. I'm rotated about positive 3. Your a is equal to positive 3. So because it's rotated about positive 3, your r is going to be 3 minus x. So your r, once again, is 3 minus x. Notice that 2 and 4 are rotated about the same thing, and your r is the exact same thing, okay? Your r simply deals with what it's rotated about. Period. End of story. So now that I have r, let's figure out h. And to figure out h, I see, do I have one function, or do I have two functions? For h, I got two functions. I have y equals 18 minus x squared, and y equals x squared. So what we're going to do is, because I have two functions, we just got to find top and bottom. So let's do the exact same thing. We first find the intersection by setting these guys equal to each other. So 18 minus x squared equal to x squared. Okay, well let's move this x squared over. I have a quadratic, so let's set it equal to 0. So I'm going to move this over and say 18 minus 2x squared is equal to 0. I can factor out a 2 and make this 9 minus x squared. And so what I get is that 9 is equal to x squared. And so x is both plus and minus 3. Get into the habit. You haven't already. Whenever you take the square root of something, it's always plus and minus. So what I have, because x is plus and minus 3, in essence, x is negative 3, and x is positive 3. And so now that I have my interval, let's see which one's on top in between negative 3 and 3. So how did we do that? Well, remember how we took my interval, negative 3 to 3, and I compared y equals 18 minus x squared and y equals x squared. Okay, I pick a random number between negative 3 and 3 to compare with, and I'm going to choose 0. 0 is a nice, easy number in between there, and so I plug it into both, and let's see what y is equal to. On the left side, I get that y is equal to 18. On the right side, when I plug 0 into there, I get y equals 0. And notice how 18 is bigger than 0. Therefore, in between negative 3 and 3, your 18 minus x squared, that is your quote-unquote top. Therefore, your h is going to be top. 18 minus x squared minus my bottom, which is just x squared, which I can rewrite this as just 18 minus 2x squared. Now that I have r, now that I have h, let's go ahead and plug it in. Your final answer, volume. Volume is going to be equal to the integral of 2 pi. My r is 3 minus x. My h is 18 minus 2x squared. I'm doing everything with respect to x, and my interval is -3 to 3.